If we are asked to prove a particular property about a quadrilateral, let's say for instance that the opposite sides of a parallelogram are equal to each other, then the easiest way to do this is to find two congruent triangles inside that parallelogram and use the fact that congruent means identical to show that those opposite sides are the same as each other. So by following the 4 steps in front of us, we'll make sure that we set up a mathematically correct proof every time. The first thing we need to do is identify a set of congruent triangles inside the given quadrilateral. And we need to make sure that these congruent triangles use the property we're trying to prove. So for instance, if we're trying to prove the opposite sides of a parallelogram are equal, then we need to make sure we pick two congruent triangles that involve those opposite sides. We then need to identify the correct congruency tests that can be used for these triangles. Remember that there are 4 you can choose from. So if your two given triangles use 3 known side lengths, then you can use side, side, side. If you've got 2 side lengths and the angle that's in between them, you can use side, angle, side. If you know 2 angles and a side, then you'll use angle, angle, side. And the last one is if you have a right angled triangle, the hypotenuse length is known, and any other given side length. Now this next step is really important. You need to make sure that the test that you're using does not involve the property you are trying to prove. If we're trying to prove that the opposite sides of a parallelogram are equal, then we are not allowed to use those sides in our proof. We need to use other known information to get to that property. And lastly, once we've worked out all of the information we're going to use in our proof, we need to set up our proof properly and make sure that it makes mathematical sense. So let's consider that example about proving that the opposite sides of a parallelogram are equal to each other. This means that we're trying to show that side AB is equal to side CD and that side AC is equal to side BD. Now, as the side lengths are the property that we're trying to head towards, we can't use them in our congruency proof, which means that we're trying to identify anything else that we already know about a parallelogram that we can use instead. Step 1 said to identify some congruent triangles inside our quadrilateral that involve the opposite side lengths. So the first thing I'm going to do is construct one of the diagonals of this shape. So let's construct diagonal BC. That gives us triangle ABC and triangle CDB that we can use. Remembering that we're not allowed to use the opposite side lengths, but anything else we already know about this parallelogram, we can go ahead and use in our proof. So the first thing we should notice is that they share this common side BC. Because it's a common side, it means that it's equal for both triangles. So we've already proven one side is equal in both. We can also use any property that we know to be true about a parallelogram that doesn't involve the side lengths. So for instance, that the opposite angles of a parallelogram are equal to each other. So angle A is equal to angle D, which means that now we've shown a side and an angle. The last piece of our congruency puzzle comes from the fact that we have parallel sides. And so in that, we form a set of alternate angles. So that gives us that angle ABC is equal to angle BCD, giving us two congruent triangles, ABC and CDB, that pass the test AAS. And because they pass that congruency test, we can then say that everything else about them are identical. And hence, sides AB and CD are identical, and the remaining sides AC and BD are identical as well. And hence we've proven our property. Finally, let's consider a more challenging example. Here we want to show that the diagonals of a rhombus bisect each other. Remember, this word bisect means to cut in half. So we're not allowed to use the lengths of the diagonals, but anything else we know about a rhombus we can use in our proof. So the first thing we're going to do is identify our two congruent triangles. We're going to use these two triangles that are opposite each other here. So we've got in triangle A, B, E, and I've labelled that point E so that I can use it in my proof. And then the one below it, so triangle C, D, E. The first thing that I can say is because this is a rhombus, all of my sides are equal to each other. It doesn't involve the property, it doesn't involve anything about the diagonal, so I'm allowed to use it. So I'm going to start by saying that side AB is equal to side DC. And so I've proven a side. Now, since I'm not allowed to use anything about the lengths of my diagonals, I'm now going to look for any angles that I could prove. Now, I do know that the diagonals of a rhombus bisect the interior angles. So it means that it cuts these angles at each corner in half. And so I'm going to use those as my final properties in my congruency proof. So I'll start by saying that angle BAE is equal to angle EDC in the triangle below it, and they're the two blue dots that I've identified. And I'm also going to say that angle ABE, which is the red cross, is equal to angle ECD in the triangle below that. The other one that I could have used is these two vertically opposite angles in the middle. So we could have said angle AEB is equal to angle CED because they're vertically opposite each other. And again, it's a property that's not the one we're trying to prove, so we're allowed to use it. In either case, we've correctly identified the test AAS and hence proven that our two chosen triangles are identical. So triangle ABE is congruent to triangle CDE because it passes the test AAS, and therefore everything else about them is the same. So that means that side AE is equal to DE in the triangle below it, and side BE is equal to CE, hence showing that our diagonals cut each other in half and therefore proving our property.